Hello friends, welcome to online school. And then so in the previous video, we had a look at how to derive product rule. Now, so let's try to look at how to use product rule. And then let's get an example, like assuming we have our function y, equal to x squared. And then in brackets, we can have x cubed plus 2, like that. So how do you differentiate such a product using product rule? So I'm going to find that this is a product and then of two sets of functions. So you have x squared and this one being x cubed plus 2. And then so you happen to note that now in this case, I'm trying it out using two explicit functions. Or, okay, let's get to it. Let's get how to work it out. So you can say that this is going to be my u. It's going to be my u. And then this is going to be my v. So you happen to find that in that case, you'll be having y equal to uv, whereby u is a function of x and then v is also a function of x. And then so how do we differentiate that, or how do we get the derived x, this product here? So you can come on and say that let this first part here be my u, and then let this other bracket be my v. So from that, we happen to find that now this is our product rule, and we want to get du dx and dv dx, then we substitute it into this formula here to get the dy dx. So let's begin. We have our u being equal to x squared, and then we also have our v being equal to x cubed plus 2. And then so let's get du dx from this. And then when you're getting du dx, you use the knowledge of how to differentiate an explicit function, because now here you have these two being explicit functions, where one variable is expressed in terms of another variable completely. So from this, we can use power rule, and then we know that du dx is going to equal to, remember, we drop the power and then you subtract the 1 from the previous power. So we shall have 2x, and then if you're wondering how we go to that, we have our function as x squared, so it means that we shall drop the power to get 2. This 2, we drop it here, we'll drop here to get 2, then x, and the previous power was 2, so you subtract 1 from that power to remain with 2x to power 1, which is the same as 2x, like that. And then so our du dx is 2x. Now let's get to dv dx also. So dv dx is going to be, and then we have our v as x cubed plus 2. So we drop the power also on this x, and to get 3x, then the previous power was a 3, so we subtract the 1 from the previous power to get 3x squared. And then so we know that whenever we differentiate a constant, we get a 0. So how do we come to that? If at all you have something like 2x to power 0, so hope we agree that 2x to power 0, it is the same as 2, because we know that when x is to power 0, it's the same as 1. So now this one here, you're going to find that when you drop this 0, you shall have 2 being multiplied by 0, then x to power negative 1. And then this 0 here will reduce everything to 0. So whenever you differentiate a constant, you'll be getting a 0. So now let's proceed. We have the du dx, and then we have the dv dx. Then let's substitute that into our formula. We have dy dx being equal to, now whichever way around, this one here, even if you begin with u dv dx plus v du dx, it's the same. So you can have v du dx, and then our v, it is x cubed plus 2, then du dx is multiplied by 2x plus our u, which is x squared, then dv dx, which is 3x squared, right, like that. And then from that, this is our dy dx, but then we can simplify it further. We can say that dy dx is equal to, this 2x can multiply everything here inside, and then we shall have 2x to power 4 plus 4x plus 3x to power 4. So this one here, it will give us dy dx being equal to 2x to power 4 plus 3x to power 4. We shall get 5x to power 4 plus 4x. And then this is the derivative of our function y equal to x squared into x cubed plus 2. So that's how we work them out. And then we have this as our dy dx, that given function. And so let's try to look at another example also. So let's try to look at another example. So if at all you also have a function, at all you have another function y equal to, in this case round you can have x plus 1 squared, and then also x plus 2, x plus 5 cubed, like that. And so how do we differentiate this such a given function? And so we can begin by getting a u and a v, and then we can just say that this x plus 1 squared, you take note, we are saying x plus 1 squared will be our u, and then x plus 5 cubed will be our v. So we shall have our u equal to x plus 1 squared, and then we shall also have our v equal to x plus 5 cubed. Then you take note, it's not that our u is going to be equal to x plus 1. So we want to get this function in the format of y equal to uv. So when you say that my u is going to be x plus 1, we'll end up with something like this. You'll have your u squared and then the v cubed, like that, which is completely wrong, and then it won't give you the derivative. So now remember, we want the whole of this to be expressed in terms of uv. So it is right to say that, or it is proper to say that x plus 1 squared, the whole of this with its power being equal to a u, and then that's the right way of doing it. So let's proceed. And then we know that our product rule states that dy dx will equal to v du dx plus u dv dx. So we have the v and then we have the u. Let's get the du dx and the dv dx. We substitute in our formula, and that will be the dy dx, or the derivative function. So we shall have du dx, this one here. So now when you're differentiating such a thing, we shall have to drop this power also. So we shall drop this power, and we shall have 2 into x plus 1. Then the previous power, which was the 2 minus 1, we shall remain with the 1. And then that is our du dx. Then for dv dx, we shall also get, we shall drop this power, and then it will be 3 into x plus 5. And the previous power was 3 minus 1, we remain with 2 power 2 there. So why am I doing this? Now this here, it's kind of related to chain rule, but you don't know anything about chain rule, it's going to be my next video. So you have to make sure that this variable here, x, it does not have any other coefficient apart from 1. So the coefficient in this case here, it has to be 1. For you to just drop this power and you subtract the 1 from it. Otherwise, it will give you a very different thing. So we shall get to that when we get to chain rule. We shall see how to differentiate brackets or such expressions with powers here. So now in this case here, it's kind of this part here which is inside, it's explicit. So you can just drop this power. And then because also you don't have any other coefficient here. Sorry if you're confused, but then we are going to look at it in the next video. So you have du dx and then you have dv dx. Then let's substitute it into this formula. So we shall have dy dx being equal to v, which is x plus 5 to power 3. Then du dx, and our du dx, it is 2 into x plus 1. Then plus u, which is x plus 1 squared. Then dv dx, which is 3 into x plus 5 squared. Alright, like that. And now this one here, it can be further simplified. This is a derivative function here, but it is kind of so enlarged. So you can simplify it, and we get to dy dx will equal to, now when you're simplifying this, you just have to look for common terms, and then you factorize them out. For example, here you can begin with x plus 5. Here you have x plus 5 to power 3, and this is x plus 5 to power 2. So you can factorize out x plus 5 to power 2 because it has the smallest power. So we shall have x plus 5 power 2 factorized out. And then you also have, this is 2, this is 3, you have no common term. So you have x plus 1 and then x plus 1 squared. We can factorize out x plus 1 because it has the smallest power, which is to power 1. So we shall also have x plus 1. And then what will we remain with? In this case here, we factorize out x plus 5 to power 2. So we shall remain with x plus 5 being multiplied by a 2. Then plus, here we factorize out x plus 1, this one here. So we shall only remain with x plus 1 to power 1. And then with also this term here 3, constant 3. And then x plus 5 to power 2 was factorized out. So we shall get to something like that. Then we shall have dy dx being equal to x plus 5 squared into x plus 1, like that. And this one here, we shall have 2x plus 10 plus 3x plus 3, right? And then after that, we shall finally get to dy dx being equal to x plus 5 power 2, then x plus 1. And this one here, we have 2x plus 3x, 5x plus 13. Plus 13. Right, and then we've reached our final derivative. And then this is what we refer to as derivative function of the given function. This is what we refer to as the derivative function of the given function. And then the function, it was y equal to x plus 1 squared into x plus 5 cubed. But then, so in most cases, you happen to find that you'll have to apply chain rule before you see product rule and quotient rule. So let's get to quotient rule, and then after quotient rule, we shall see how to use chain rule in these cases.